In this video, we're going to have a look at some of the terminology that you may see in probability questions. In particular, we're having a look at the words not, and or, and see how we actually interpret them in a problem. In this first example, we're having a look at the word and. The question is, what is the probability that a chosen letter from this group of letters is read and a vowel? So obviously we need to look at the letters that are read and look at the letters that are vowels, but decide what the word and actually means. And we can think of and as meaning like an intersection. It means it has to satisfy both conditions expressed. In other words, a letter has to be read and a vowel. Let's break the problem down to make it easier. What we'll do first of all is we'll have a look at all the red letters, and we've grouped those in the bottom left-hand side of our diagram. You can see the letters there are A, O, M, S, and X. Then we've grouped all the vowels together in the right-hand side of our diagram. They're the letters A, O, A, E, E, and U. So the letters that satisfy being both read and a vowel must belong to both groups. And there are only two letters that are in both groups. That's the letter A and the letter O. So the final probability of a letter chosen being read and a vowel is 2, because that's the favourable outcomes, out of 14, because that's the total number of letters. Let's have a look now at the use of the word or. And our example here is, what is the probability that a chosen letter is black or a vowel? Now the basic idea of the word or in this case is that the letter can be black, can be a vowel, or it can be both. So we're looking at a much bigger group as opposed to using the word and. Let's do like we did beforehand, and we'll just look at the black letters in isolation first and the vowels, and then we'll see if we can group them based on the word or. So we can see that the number of black letters is just 2. There's only E and T that fit that particular group. In the bottom right hand side of our diagram, we've got all the vowels, and that's the same as we had beforehand. There are 6 of those: A, O, A, E, E, and U. Now let's have a look at what the word or means. Now or means that it can be one or the other or both. We consider this like a union. It brings everything together. So we can see here that we've got the letters A, T, O, A, E, E, and U. Make sure you take care when you bring all the letters together, because some of the letters are in both groups, but we still only count them once. An example in this case is there is a black letter E, which happens to be in both groups. But when we put it in our final group, we only state it once, because there is only one in the original diagram. So just repeating, the probability of a black or a vowel is 7 over 14. Let's have a look at another example now where we use the word not, and we've tied this in a previous video with complementary events. In this example, we're asking the question, what is the probability that a chosen letter is not blue? Now if you see that, you can go through and count all the letters that are not blue, but it can be time consuming, particularly if it's a big group of letters or a big number of possible outcomes. So what we will do is we'll have a look at all the cases that are blue. There are 4 letters here which are blue, so the probability of being a blue is 4 out of 14. Therefore, the probability of not being blue is 1 minus 4 over 14. That works because the total probability that you can achieve for any group is always 1. So if we subtract the probability for a blue, that means that the remainder gives us the probability of not being blue. In this case, the solution is 10 over 14. So the probability the letter is not blue is 10 over 14.